Okay, some algebraic proof questions here. So prove that 3n plus 1 all squared minus 3n minus 1 squared is always a multiple of 12 for all positive integer values of n. So we're going to need to expand and simplify first. So 3n plus 1, 3n plus 1, take away 3n minus 1, 3n minus 1. If I expand the first one, 9n squared plus 3n plus 3n plus 1. Take away, now I'm going to keep this in the bracket because it's subtraction. I'll explain why in a second. You get 9n squared minus 3n plus 1. Simplify both, just the middle bits because they both have n. Now the reason I kept it in a bracket is because I've got to take away that whole thing. So 9n squared take away 9n squared is going to cancel. 6n subtract minus 6n is going to give me 12n because I have to add the 6n. And then 1 take away 1 is also going to cancel. And now I've got to explain why. For any number n, that's always going to be a multiple of 12, well, it's because there's a 12 there. So 12 times anything is going to be a multiple of 12. Right, second one. N is an integer. Prove algebraically that the sum of n plus 1 plus n plus 1 is always a square number. So n plus 1 plus n plus 1. Right. Expand the first bracket, n squared plus n plus 1. Excuse me, n squared plus 2n plus 1. Now, if you're ever asked to prove that something is a square number, you want to think about factorizing it, and the bracket's actually going to be the same. So this is going to be n plus 1, because 1 times 1 is 1, and 1 add 1 is 2. And then I can rewrite that like that, n plus 1 all squared. And whatever number you plug in, you're going to add 1 to it and then square it, which means it's always going to be a square number. So that's the proof.